In this video, we will see how to characterize a screen or a facing. So the first thing to do when we open a RoKCell is to go to mode and screen mode, or I can directly click on this button here. When I'm in this mode, then I can load some measurements of facing screen backed with plenum. So here I click on this item. I have three samples which have been measured, so I can load the three of them. I will go on the first one for the characterization. So what we can see here is the sound absorption coefficient of the facing screen with the 200 millimeter plenum behind it. So if I go on this icon here to characterize, it's like for Pros Material, I will have a new window which is open, but only one tab on the left. So I will click on this tab. And on this tab, I have two parameters I have to estimate. So the first one is the airflow resistivity, the second one is the real part of the dynamic mass density. That will give us estimation of the porosity and tortuosity and the perforation radius of the screen or facing screen. So here we see the thickness of the screen, 1.65 millimeter. The plenum was 200 millimeter thick, and the measurement have been done in impedance tube with a radius of 22.22 millimeter. Now I have to move my red and green vertical lines in a frequency range where I have a good signal to noise ratio. So it's in, for example, this frequency range or this one, but not in the resonances at the resonances of the air gap because we have a very low signal to noise ratio, and so a not so good estimation of the airflow resistivity or the real part of flow, which is these peaks here. So I can have this estimation, for example. I can keep the probabilistic estimation or go for the mean value. If I have almost the same results in a frequency range, it means that there's no strange results, at least in this frequency range. So other value is okay. And then we'll estimate the real part of the mass density here, which give me a porosity with this value, this kind of resistivity, tortuosity, and perforation radius. Of course, if I have a direct measurement of the resistivity, I can click on this button, go for direct measurement, open a file. Here I don't have any file, so I just get back to estimation value, and this estimation value is this one. So we have an estimation in black, which is quite okay. So the higher value of the sound absorption are okay. The lower values are a bit dependent of the impedance tube, so the radius of the impedance tube, of the possible vibration of the skeleton of the facing. So we can see here in this frequency range, we have an important impact of the vibration of the skeleton of the facing screen with this peak here, and it also impact this part of the frequency range a bit before. So we can say that we are okay with these estimations for the parameters. So I click accept characterization, and I will have to enter a name for my project, RKS project. So I will be able to open it later. And then I will get back to my first window, and you can see that the values have been updated for my my first sample of my facing. And what I can do is instead of doing one by one all the characterization, I can try, if I'm confident, just go on the first one I've just done, right click, apply to all selected samples, and it will keep the same frequency range for the resistivity and the real part of the dynamic mass density for all the other parameters. Then I can also, of course, check for sample 2 or sample 3 if the results are okay or not. You can see that there's other options here on the graph, and there's also a FEM analysis tool. So if we click on it, instead of making a simulation assuming sliding condition, so by default it's sliding condition, I can make a bounded condition of my screen inside my tube, add some leaks, and if I want, I can also add some elastic behavior of the skeleton of the facing. So if I know the mass density, the Young modulus, the Poisson ratio, and the damping factor. And if I click on compute, I can have an estimation that will appear in orange with this finite element analysis. Oh yeah, don't need to have elastic, should be rigid, otherwise there's an error. So, and here we have an estimation, but of course it's finite elements. So at higher frequency, I don't have enough finite elements. So the higher frequency range should be disregarded, but otherwise it's okay. There's no big impact here because I don't have any elastic parameters. And we can save the FEM simulation clicking on this icon. And then when everything is okay, I can export all my results as a grid, so a TXT file, or I can export the black line, which is the mean value, the simulation using the mean value of the parameters, as a RoK file to be open with the with AlphaCell. I can also export the material as a XML file, and so I will be able to open it in AlphaCell in the database management of RoKCell. I can also export only the picture for report. Option is just about the languages, and help is just the usual help. And that's it for our rough characterization of the screen.